Hi, this is Calandra. In this video, we're going to discuss how to graph a line given its equation using intercepts. To graph a straight line, we minimally must have 2 points. Because if you're dealing with a straight line, once you know 2 points on your graph, there's only one option for what your line is going to look like and the direction that it's going to go in. So just illustrating, as long as you know 2 points on your line, you're going to be able to figure out what its graph looks like. Although any points will work, meaning as long as you have any 2 points on your graph, you know what your line will look like. You can use the intercepts of your graphs to graph your lines. So recall that the x-intercept is the point where a graph crosses the x-axis. To find it, we set y equal to 0 and solve for x. Okay, similarly, the y-intercept is the point where the graph crosses the y-axis. To find it, we do just the opposite. We set x equal to 0 and solve for y. So just a quick illustration of this. We have our x and our y-axis. The x-intercept is any point that's going to be on your x-axis. So if you think about what the coordinates of that point look like, well, my x, we're going to have some value since I've moved, in this case, to the right. But since we have not gone up or down, the y-coordinate is 0. So if you can think of the graph, you can always remember to find the x-intercept, you set y equal to 0. Similarly, for any y-intercept, the x-coordinate will be 0. So you would just plug that value in your equation, figure out what y is, and you have your y-intercept. So in this example, we want to find the intercepts algebraically. Algebraically means you want to show your work. And then use the intercepts to graph the following equations. Okay, so let's start off with our x-intercept. So to find the x-intercept, we set y equal to 0. So we have 0 is equal to 5x minus 10. I'm going to add 10 to both sides. So we have 10 is equal to 5x. Divide both sides by 5. And we get that x is equal to 2. So my x-intercept is the point 2, 0. Well, now let's get our y-intercept. The y-intercept is usually much easier. We set x equal to 0. So we'll have y is equal to 5 times 0 minus 10. Well, 5 times 0 is just 0. Minus 10 gives us negative 10. So remember, we set x equal to 0. So the coordinates for our y-intercept are 0, negative 10. So now that we have those 2 points, we can sketch a graph of this line. So 2 for my x is going to be somewhere over here to the right. And then I have a y-intercept down at negative 10. So my line will be some type of rising line, and this is a rough sketch of it. Now when you're graphing, it's possible to use a different scale on your x-axis and your y-axis. So I just wanted to mention that. If I drew in a tick mark for each of my units, okay, so I have 2, notice I'm not using the same spacing on my y-axis. That's okay as long as everything on your y-axis is equally spaced, similar for your x-axis. Okay, for part B, to find our intercepts, this one is not written in slope-intercept form. So one intercept is not really any easier than the other. So for our x-intercept, we're plugging in 0 for y. So we have 2x minus 3 times 0 is equal to 1. And we get 2x is equal to 1 because 3 times 0 is 0. Dividing by 2, we get that x is equal to 1/2. So our x-intercept is at the point 1/2, 0. For the y-intercept, we're plugging in 0 for x. So 2 times 0 minus 3y is equal to 1. So we have negative 3y equals 1 because 2 times 0 is 0. Dividing both sides by negative 3, we get y equals negative 1/3. So our y-intercept is a point 0, negative 1/3. So to graph it, again, we just have a point on our x-axis, a point on our y-axis, so we don't really have to worry about our tick marks. 1/2 is going to be somewhere positive to the right. Negative 1/3 is going to be somewhere negative down below. And this would be a rough sketch of this graph.